Hello students, welcome back to Vask Academy. Today I'm going to discuss the linear combination of example 3. How the matrix generates a space. Right? For example, you have the matrix 2 cross 2 matrix. The example is that to show that these matrices generate M2 cross 2 matrix. F is basically talking about the vector field. Basically, this is the vector field F. Let's start and check whether it generate these M2 cross 2 matrix or not. Let's start. So by the definition, in solution we can written as let we choose a matrix which belongs to M2 cross 2 everywhere the field, and the entries should be scalar, and scalar will be related belongs to our field F. For example, let A11, A12, A21 and A22 belongs to M2 cross 2 matrix over field F. So we choose some arbitrary scalars. For example, let A, B, C and D belongs to F. Also these quantities scalars belongs to vectors. So by definition of vector fields, by linear combination you can say that a vector term of this vector is 1 0 0 plus b term of this vector is 0 1 0 0 plus c vector is this vector 0 0 1 0 and plus d vector is equal to this matrix 0 0 0 1. Here is basically 0 and 1. Now we are to generate this matrix. Then we have the supposition of the matrix is 2 cross 2 matrix. Here the entries is equal to A11, A12, A21 and A22. Right? So the first step is that going to multiply this term. So if you notice that if A, here is term first entry 0, here is first term entry 0, here. If you're going to the truth, if you check that, this is basically a matrix. Now we're going to multiply and check whether it is true or not. So here is to notice that A1, other you have any other entry? No. So it is equal to column by entry, that is A11. Right? So try to introduce, here is second entry 0, here is B, here is another 0 is 0. So we have the second entry element is related to A12. Right? So the third entry, if you wanted to multiply into second row, here is entry A is 0, here is B is also 0, here is C. So we have C is equal to, this is A21. So basically we can written as A21. Right? So if you're going to multiply the fourth entry of the second row, so we notice that here is entry is A22. Right? So putting these values in equation number, this expression, if you're going to remove it and check it whether it is true or not. Right? So I'm going to remove from our side, upward side, so check, so we can easily check which is the true condition or not. So for this checking the expression, so we can choose this value. First put in your right hand side of the expression, left hand side of the expression, values of A is A11. Here the matrix A1 0 0 0 plus we have the value of B term is A12, that is A12. So we have the entries 0 1 0 0 plus we the C matrix, we have the entry, here is A21 and the matrix is SAM 0 1 0 and plus D matrix, D has the entry A22. So we have the entries values 0 0 0 1. So right side of the expression will remain same. So we have here is A11, A12, A21, A22. So multiply internal side. So in the matrix form, so we can written as, if you notice that a11 plus 0, a21 into 0, a22 into 0. So we have the entry a11. Right, so if you're going to multiply a1 to second entry of the first column, first row, so here notice that is 0 plus a12. So here is the term 0, here is the term 0. So we have the entry is the equal. So if you're going to multiply by a11, so here is term 0, a12, here is term 0. If you want to multiply, here is a21. Right, so if you're going to multiply the second row as for the second entry, so here is the term 0, a12 is 0, a21 is 0, and we have here is a22. Right, so if you notice that this is your left hand side of the expression, so which is equal to same as a11, sorry, here is a11, a12, a21, and a22. Right, if you notice that left hand side of an expression is equal to right hand side of the expression, so we can written as, if I'm gonna to remove this matrix from this side, so we can say that left hand side is equal to right hand side. Hence these matrices generates M2 cross 2 matrix over field F. So this is the way you can calculate, you can check whether the matrix generate any space of n cross. So you can also prove for n cross n matrix, right? So we can easily prove the behind this theoretical, basically all these proofs on the base of the definition of linear combinations. So this is the process. You can use any matrices. You can choose R2 space or 3 space of any sort of vectors, and you can also prove for matrices. Here I'm going to stop my lecture. If you have any query, any sort of question, you give me a comment. I will discuss in next video. Please like, share, and subscribe my channel. So till next video, bye bye.